All right, let's take a look at problem 13 in section 5.1. The question itself in the book reads, write a word problem for 2.5 times, that's a times 3.5. And the book says word problems will vary. What they need for us to do is to go back and look at the definition of multiplication. So if you look at section 4.1 on page 143, then you'll see that we're told that the first number is the multiplier and it's the number of groups. And the second number is probably called, let's see, the multiplicand. It's the one being multiplied, and it tells you how many are in each group. So the number in each group versus the number of groups. So however you word your problem, you have to have 2.5 groups such that in each group there's 3.5 things for a total of the multiplication. And then their visual is just a grid diagram, right? So in their grid, they have the size of a 1, 2, and then visually this is half, right? So 2.5 going down. And then in the columns, we have a whole, 2, 3, and again a half. So we're getting 3.5 by 2.5, right? Or 2.5 times 3.5. Then part C is the math and part D is the more information. So however you word your problem, you want to focus on M being the number of groups and 3.5 being the number in one of those groups. Now, let's look at part D. So part D, identify the 4 products by the distributive property in part C. And I drew it for you in the image too, right? We had one, get my pen back up. We had 1, 2 going down, right? So 1, 2 going down, and then our little half, and I drew a solid line across there. Then we had a whole 1, 2 going across, and we drew a line down there. And so if you look back at our previous drawing, then we have split this the same way, so that in one quadrant you can see the 2 times 3, the 2 times 1/2, the 1/2 times 3, and the 1/2 times 1/2. And generally I label these in order to match them up with my partial products. So if we go back a page and look at 2 times 3, 2 times you can see here that from our drawing where we cut this, right, to give ourselves the 2 times 3, Here we have a 2 times 3 quadrant, which is right here in our distributive property for part C. Okay, we also have here a 2, 1, 2 times 1/2, right? Because this space here is only a half in size. So there's our 2 times 1/2, which is right here. We also have in this spot a little half times 3, because we only go a half right here, but then we go 1, 2, 3 across. There's our half times 3, and then our half times a half, which is right here. So if you have colors, you can illustrate through colors. I often will label, right? Just A, B, C, and D if I don't have colors. And part E, now rewrite the mixed number as an improper fraction and solve again. So let's go back to our page we were on. And here they split it up for us into mixed numbers. A lot of times what we do in class, however, is we take our image here, this very first one, and just didn't want to be bigger. And then we do something like, if we cut them all into half shapes, making all the sizes the same. Now every line itself represents the distance of 1/2, right? 1/2. And we have across the top, we have 1, 2, 3, 4, 5, 6, 7. We have 7 of these halves. And going down, we have 1, 2, 3, 4, 5. We have 5 of these halves. So we can see in mixed numbers as well that 2 and 1/2 times 3 and 1/2 is the same as 5 halves times 7 halves. Now we can see that each square itself, let's focus in on where we can actually see a 1, actually, because that's a little like quadrant there. Let's look at what a whole 1 looks like, right? So if we focus in, this was the line for 1, and this was the line for 1. So a whole is a square, and 1 box is 1/4 of a whole, right? So we know however many boxes we have them in sizes of 1/4. And now what we can do is literally take our 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6, 7, and just count the number of pieces that we have here. 35 boxes, each of size 1/4, right? Which again, we could simplify to not 9, it's almost 9, it's 8 and 3/4. Yeah, 8 3/4.